Alright guys, let's see how we can solve the question from the chapter 4 of Engineering Mechanics by Meriam. And we have the Jaws of Life device that is utilized by rescuers to pry apart wreckage, so helping to free accident victims. And if a pressure of 8,000 pounds per inch squared is developed behind the piston at point P, so the whole force that we have from the piston is going to be 8,000 pounds per inch squared, and we have the area of the 20 inches squared. There's a typo in here, so inches squared. We need to determine the vertical force R, which is exerted by the jaw on tips on the wreckage. So we were talking about the force R that is applying in each of these jaws. So we have one for the top part and one for the bottom part, and we have a note at the end that the link AB and its counterparts are both horizontal. So we can see that our members is something like this. And same story for the bottom jaw. And they're attached to two members that we know the force in there is horizontal as well. So as I mentioned, we can pick either the top jaw or the bottom jaw in order to find the force R. So I'm just gonna pick the one that we have at the bottom jaw, and the force R that is applying in here would be from here to this part. And if you look at the figure, you see that you already have the force R that are applying to the wreckage, but like what we are interested in here is the force that it's applying to the jaw. So since we are drawing the free body diagram for this part, we're gonna have something like this, and this is gonna be, try to draw it a little bit better. All right, so this is going to be our force R. Again, this is the force that is applying from this brown part to the jaw, and that's why we're considering upward. And we have basically the force that is distributed to the point being here from the piston. So as I mentioned, the piston has a force of 8,000 pounds per inch squared. And if we multiply this by the area, which is 20 inches squared, is going to give us the total amount of the force. So it's going to be 160,000 pounds. The force in the piston that is applying in these two members. So each of these links, AB is going to exert half of that part, half of that force to the jaw. So if we want to find the force in link B, we basically have 160,000 divided by 2, which is going to be 80k pounds. So 80,000 pounds. And again, we divide it by 2 because we have a symmetrical tool. So whatever is happening on the top part, we're going to have the same thing in the lower jaw. So that's how we figure out the force in the link AB, which is applying to point B, and we're going to have a pin at point C. Again, for a pin, we need two forces, one horizontal component and one vertical component, and this would be our x and y axis. We are in equilibrium, three equations, sum of all forces in x equals 0. Same for y, and we're going to have one moment equation as well. So since we are interested in r, if we just do the moment about point C, counterclockwise positive as always, we should be able to find the r in one shot in here, and we don't need to use the first two equations that we have. So the moment of r about C is going to be a counterclockwise moment, so positive r times, we need the vertical distance from C to the line of action, so that's going to be 18 inches, and we're going to have the moment of the 80,000 pounds. That's going to be a clockwise moment, so negative. And the distance would be vertical distance to the line of action. So basically I'm just gonna clean the figure. We can see better the distance. So the distance that we have would be this distance in here, which is 4 inches. So this will be equal to 0. And let's see what we get for our R. So 80,000 times 4 divided by 18. That's going to be 17.8 pounds. And this is going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.